Hello everyone, Ziyaan Sir this side. Let's start with my brief introduction. I've done my MSc Zoology. I've qualified CSI and JRF with all India rank 65. I've qualified SET Maharashtra as well, and one more exam that's called as PET, stands for PhD Entrance Test. Currently I'm doing my PhD at SPPU Pune. Our today's topic is here. Today we'll be dealing with the types of the chromosome. As a brief revision, I'll be telling you, and the last topic we have done with the centromere. Now, types of the chromosome on the basis of their position of the centromere. The first one I'm dealing is called as telocentric. Okay, telocentric are basically rod-shaped chromosome with the centromere occupying a terminal position. One arm is very long and the other is almost absent. Here, somehow like this. This is the shape of a telocentric chromosome. So please deal with telocentric chromosome has an shape of the alphabet which is called as small I. So please deal with small I. Okay, done. Now the second one, acrocentric. They are the rod shaped chromosome having subterminal centromere. One arm is very long and the other is very small. Here you will be having like the shape of the chromosome is something like this position, something like this. You are having your centromere here and the shape will be this. So please deal with, again, acrocentric are the rod shaped chromosomes having subterminal centromere which is not in the center. One arm is very long and the other is very small. Now here, like the third one we are dealing called as the submetacentric. Again I'll be going for submetacentric are having a special shape of the alphabet called as J or L shaped chromosome with the centromere slightly away from the midpoint, so that two arms are slightly unequal. Something like I can draw them, something like this. This is the shape of submetacentric. This one is the largest one and this one is the slightly smaller one. So please deal with. They are making a shape of alphabet called as J or L. Now the last but not the least one, the metacentric chromosome or the V-shaped chromosome. Okay, V-shaped chromosome, which are the metacentric chromosome because the centromere is present in the middle of them. I'll try to draw that as well. Okay, this is a metacentric chromosome for me. Here the two arms are almost equal to each other. Please do remember, almost equal to each other. Again I'll be going for all of them one by one. The first one was our telocentric, in which the one of the arm was very huge, the other arm was quite smaller or somehow like it was absent at all. Deal with. The second is the acrocentric, in which like the one of the arm is very long and the other is very small. The third one was submetacentric, in which you have chromosome with the centromere slightly away from the midpoint, so the two arms will be slightly unequal. And the last but not the least one, the metacentric, which is making a V-shaped structure which is having almost equal arms. One important thing you should be knowing about, like this, if you are studying the chromosome, the upper arm of the chromosome is called as a P arm, whereas the lower arm of the chromosome is called as Q arm. Please do remember the case, the upper arm of the chromosome is called as a P arm, the lower arm of the chromosome is called as Q arm. Okay, now please do remember, I've told you beforehand, hopefully you are remembering the case. I've told you about the primary constriction and I've told you that I'll be dealing with the secondary constriction in the next lecture. So secondary constriction, the primary constriction is basically centromere and the secondary constriction is telomere. If you will be asking me to draw the structure of a chromosome, I'll be just drawing like this structure. Okay, and this is the centromere for me. This center point is the centromere for me, that is called as the primary constriction, but still these two ends are telomere for me, which are called as a secondary constriction. These are the tips of the chromosome. They are the tip of the chromosome which are rounded and sealed. They are called as telomeres. So please deal with the thing. And there are some parts which are like beyond the telomeres. They are called as the satellite parts. Please deal with the part which is beyond the telomere is called as satellite. Okay, go for. Now, like the one of the most important thing which I wanted to discuss in today's lecture was the structure of the DNA, like how the chromosomes are packaged. So basically here, if I'll be dealing, there are two units of the packaging of the chromosome, that is called as structural proteins and the second is nucleosome. So the first thing we'll be dealing with the structural proteins, as like I've told you in the earlier lecture the DNA is basically eukaryotic DNA is bounded by histones. Now we'll be dealing with the detailed study of what histones are. So these are basically basic amino acids, especially the two amino acids called as arginine and lysine. Please deal with, there are three types of basic amino acids, that is lysine, arginine and histidine. So histidine is absent in histones, as like the word is pronouncing histone, we think like the histidine is present in the histone, but it's not the case. I'm sorry, it's the lysine and the arginine which are present in the histones. Basically there are 5 different types of the histone proteins. I repeat, there are 5 different types of the histone proteins, and they are divided into 2 categories. That's called as nucleosomal histone and H1 histone. Please deal with nucleosomal histone and H1 histone. If I am dealing with the nucleosomal histones, they are H2A, H2B, H3, H4. These 4 will be forming nucleosomal histone, or what we call as the core of the nucleosome. I repeat, they are called as the core of the nucleosome. And H1 histone, they are basically very tissue specific, and they are present almost like 180 base pair or slightly 200 base pairs away from each other. So if I'll be dealing with the nucleosomal structure, I'll be just giving you the structure, that the nucleosomes are fundamental packaging units of chromatin and give the chromatin the beads on the string appearance. I'll just draw that. Okay, here if I'll be drawing, like this is a histone molecule which is having all the 8 histones are octameric. Histones are octamer. Hopefully you know what is the meaning of octa. Octa means 8. So basically histones are octameric. And what is like the configuration of the histones? They are H2A, H2B, H3, H4, H4, H3, H2B, H2A, something like this. This is the whole octamer which is formed by the histone molecules. Please do remember, this is the configuration of writing a histone octamer: H2A, H2B, H3, H4, H4, H3, H2B, H2A. Again I am repeating, H2A, H2B, H3, H4, H4, H3, H2B, H2A. Okay, please deal with. And what is the location of H1? So H1 is present here. H1 is not in the octamer, rather H1 has its own structure, and after each octamer of the histone, H1 is present, which is also called as linker DNA, or spacer DNA. Please deal with, like these are like the nucleosomes, which are fundamental packaging unit of chromatin. They are disc shaped, they have 10 nanometer diameter, and they have 1 core particle and 1 linker DNA. So this complete structure will be a nucleosome. Hopefully this lecture is beneficial for you. Thank you very much. As I have already asked you, please go on to the Unacademy as well and follow me on their profile. Please deal with the case, because I'm not asking you, I'm just telling you to go on to the Unacademy. Okay, thank you very much.